control on melioidosis. So I would like to share with you my presentation is about from the laboratory base to deployable molecular detection of Burkholderia pseudomallei. Burkholderia pseudomallei is a soil bacteria that is present in the tropical countries, and also in other Australia, Southeast Asia, India, Brazil, and many tropical countries. So this bacteria, Burkholderia pseudomallei, cause a disease called melioidosis. So the public need to know about the disease also, melioidosis, because a lot of reports in the country, especially after the flood, there is an increase in cases of melioidosis in Pahang. Patient admitted to hospital, and this patient become very ill. The bacteria enter the bloodstream, and it attacks the organ, the lungs, the liver, the intestine, and then those who are not good in the immune system, they can, especially if they are diabetes, they are very at risk of getting infection. Similarly, like COVID-19 now, those who are died on elderly people, and also those who are immunocompromised, they have diabetes, arthritis, their immune system is low. So, me and Prof. Taj was working in UNIMAS. So I was working in UNIMAS in the late 90s until 2006. So I did quite a number of research in East Malaysia, mainly in Sarawak, isolating the organism Burkholderia pseudomallei in the remote areas. It seems that there are people who are at risk of melioidosis, engaged in agricultural activities, and in Sarawak there is a huge hydroelectric project in Bakun. So I've been monitoring the soil in Bakun, and we have cases from those Bakun areas. We will discuss afterwards. So, in the detection, normally melioidosis occur in poor countries, especially in those states. Some are very not good in their laboratory facilities, and they may miss the diagnosis of melioidosis. And then they have limited electrical supply, and also the lack of accessibility. Some places are very remote, and those people may be exposed to the bacteria, the soil bacteria. So this is the culture. They grow the bacteria from the soil or from the person, from the blood. They may get a sample from the body, and they grow the bacteria. This is what it looks like, a wrinkle colony. And then if you do the staining, you can see the bacteria under the microscope. It's a bacilli shape, rock. Okay? So the microbiologists need to know the characteristic of the bacteria. So now there is an importance of molecular detection, because if you culture the bacteria, it will take many days, 1 week, you can identify the bacteria. But if you do next generation sequencing, you can identify the bacteria more rapidly without doing the culture, without growing the bacteria. now we have the PCR technique. So, my supervisor, Tim Ingalls, I think Ross Tash have Google Tim Ingalls. In fact, we have started the deployable detection, taking sample in West Malaysia, East Malaysia, way back in 2000, 2003. And then we're going to have done in Sri Lanka and also in Brazil. And then we have been collaborating with Western Australia and also in the Northern Territory, the Melioidosis in the Northern Territory. Okay, so we send sample and then sometimes we do PCR, conventional PCR, and then now we have the real-time PCR. Now they detect COVID-19 using real-time PCR. So now people are moving from the conventional method, from the culture method into molecular detection using PCR, real-time PCR. Okay, this is the history way back in 2000, 2003, then in 2008, I was in UNIMAS, 2003, I was in UNIMAS, and then way back in the 2005 in Malaysia. Then in West Malaysia also, we went to Royal Bloom to take sample. Okay, you remember in 2014, March, in 2014, I was in ground zero. The ground zero is in Kota Baru. This is the Wakaf CA, I think. The water start rising. We just arrived there, and then we went to the pusat pemindahan, and we conduct mobile clinic. And then after a while, water get rising and then they move from the pusat. And this is on the way to Jalan Cepal. On the left and right, the river, the flood. So it seems there's evidence that after the flood, more cases from melioidosis in Pahang, also in Kelantan. Okay, those days in 2015, after the flood, so 20 cases in Pahang, Kelantan, and one in Perak, also in Johor. So that's important of we detect the bacteria in the environment, we monitor. And then normally last time we use the media, culture, and then we confirm by PCR. So this is what we do using culture method. Of course, in the bottle, we grow, we put the sample in the bottle, and then we culture, and then we grow the bacteria. So this is the paddy field we did in Sarawak, in the commercial paddy. So we have using PCR we can detect Burkholderia pseudomallei. Those in Gedong, I think from Awang village in Gedong, in Sarawak. Then we had in Kapit area a lot of logging activities in the hinterland and also in the village, in the internal part of Sarawak. So we see few Burkholderia here. But there are also other species of Burkholderia. Burkholderia, there are many species of Burkholderia. So for a doctor, the specific organism is very important. To detect organism is very important for the doctor to treat the patient, to diagnose the patient having Burkholderia pseudomallei infection. Then we have the paddy field again, just now, we had. Then again, soccer field, in the playground area. Before that, there is school student play soccer because a lot of puddle, water, and then they play, and then they got infection on the skin due to this organism. So we were asked by the health department to investigate. So we found quite a number of Burkholderia pseudomallei in the various quadrants of the school compound. So, see the soccer field, 11 out of the sample, 26 samples, 11.5%. Another one, very high, 47%. And then in the playground area, 13%. And then in the telematch, they play telematch, 21% of those Burkholderia pseudomallei was isolated and confirmed by PCR. So this is Burkholderia pseudomallei, different type. So we do a fast field gel, usually a gel, and we run it, and then we do a dendrogram. I think originally from computer analysis something. So they group it based on the similarity of the organism, based on the similarity. So these are quite close. This is quite close. So there are cluster of Burkholderia pseudomallei, and then we compare the environmental Burkholderia pseudomallei from the soil and also from the patient. The patient in hospital admitted a culture, and we mesh them, and we found that they are very closely related. So at least we can know by this method, we can see which location of the bacteria in Sarawak, in bowel, maybe in bowel, patient from bowel, and then the soil bacteria, we mesh them. And then we see the relationship of those bacteria. Okay, so we also do taking blood, using to see the antibody for the Burkholderia pseudomallei. So to make sure to detect whether these people are exposed to this bacteria. Okay, so PCR now is important to detect. That's what we are doing at the moment, to take soil sample and we do a PCR without doing the culture of the bacteria. So this is the place in a commercial paddy where they plow the paddy using machine. So it seems using machine, there are less contact with the soil. So when there are less contact with the soil, there are very low exposure. So the machinery is important to prevent contact with the soil. So we found very low incident of melioidosis among the workers in the commercial paddy field. This is Logan, I think Prof. Touch know this place. We were there before. So we take soil sample over the area and also the forest. So this area is very different. This is a peat swamp forest. It seems acidic, very acidic. I went to church camp, also very acidic soil. So may not be favorable for the Burkholderia pseudomallei. But another one is mainly in the paddy field. Some of them practice hill paddy cultivation among the group of indigenous people. So I mentioned a hydroelectric project. I think now it's already been completed. So we were monitoring during the construction, and we took soil sample, and we managed to isolate Burkholderia pseudomallei. People there, when they are at work, there can be injury, isn't it? The injury, the bacteria can enter the body, and they can become infected with Burkholderia pseudomallei. All right. Okay, so I hope the modeling can do better mapping, where I mesh the cases of melioidosis in yellow, and then I did the soil and water sampling in the area, in carpet area, balcony area, Tubau, because quite a number of those working in the logging activities, they are infected, especially helicopter logging. Because during the Vietnam War, during the Vietnam War, it creates an aerosol, doesn't it? It creates an aerosol, and then the bacteria can enter by inhalation or enter the body. So similarly, in Sarawak now, because of the logging forest is on the hilly part, very difficult to log using local transportation. So they do helicopter logging. So quite a number of people become infected. So one is in the Cebu, the Rajang River Basin. The inland part is the Bakul. So during rain, sedimentation, they can carry the bacteria through the rivers and spread into the Rajang River Basin. So the cases of melioidosis admitted to Cebu Hospital. Okay, so this is the sampling in Logan Bunut and also in the village in the Sarawak. Okay, in West Malaysia, very limited data available. We didn't do Terengganu, so we did in Purwakarta, for isolate, in Langkawi, one isolate, and also in Pedi Field in Kanga, village in Muar after the flood, and then Bagansara in Perak, and also in Johor. So this is a summary of East and West Malaysia, isolation of the bacteria. So now we are doing in the lab there using mini computer. It's a portable computer that can be carried into the locality. So hopefully in future, if the facilities are available in Kenyah, then we can do in the field. We can do the detection in the field. That's the aim. So this is a soil sample. We analyze the soil sample, and we do the DNA extraction from the soil, and then we do the PCR, and then the real-time PCR connected to the computer, and then we can see the pattern. This is positive for Burkholderia pseudomallei. The intensity of the product of the PCR. So that's about all my presentation. Again, I welcome question. We also
can you explain how does melioidosis enter into our food system through plant or animal food base?
theoretically, the disease can be transmitted, like Vietnam aerosol in Vietnam from the helicopter, aerosol air, and most of the cases, I think 70% of the cases affect the lung. Number two, food. In Sarawak, there's the manager of a company, a New Zealander, had melioidosis, and we asked to investigate. They are logging manager in Sarawak. So we went to the camp in Tuli upriver, and then we investigate the water supply, where they drink water supply, and we found that the water supply is positive for Burkholderia pseudomallei. So there is a possibility that the water supply is the cause of melioidosis by ingestion. Same thing with incident in Pahang, where there is a case of leptospirosis and melioidosis. One person died. Then the rescue people went to rescue the bodies, through the river, and a few days later they developed melioidosis and leptospirosis. So possibly that they may have ingest water. You mentioned about plants. That is still under investigation in Australia, whether this Burkholderia pseudomallei present in plants like paddy field, and animals in the grass, for example. The animals can.
The reason I asked the question because we have our friend Dr. Azman from Aquatrop. They are doing a lot of aquaculture. So they have shrimps, various type of fish. So that's my concern. Will that enter into the food system?
Are you aware that there's a study now? They try to investigate COVID-19 virus in fish in the market. I think USM is doing investigation. Possibly in food can be contaminated with the bacteria. Animal can be infected also, right? In sheep, in pig, they can be infected. So, yeah, important.
We have cases in the zoo animal. Previously, they called Pseudomonas positive of this melioidosis and been well recorded in the zoo animal. Yeah, also in I think orangutan.
But in case of aquaculture or fisheries, I think I do have Azra here, but we never heard I think about this melioidosis for aquaculture. So normally in aquaculture or fisheries, they're being affected by specific pathogens.
E. coli.
E. coli partly water quality, but more or less we are dealing on the early mortality syndrome caused by Vibrio, genetical and so on. So yes, very interesting, Prof.
The reason being he is using Pseudomonas, Burkholderia specific primer, meaning that the primer would target for those organism only. It will not detect any other organism.
So you can have Salmonella primer. If you want to detect Salmonella, you can want to detect.
So it might be good.
You can use the same model. Salmonella have been done, PCR have been done.
So in terms of food safety, then we can say you screen for Salmonella You screen for melioidosis, any potential, we don't know. It can be primary infection, it can be secondary.
So that we can use the same primer.
Correct, correct.
Specific for salmonella,
Salmonella.
typhi, salmonella, paratyphi, there are many species
From
of salmonella causing food
waterborne
poisoning.
disease.
And the E. coli, there are also the pathogenic E. coli. The one 0157 E. coli, but much more severe. It can cause contamination in vegetables and also in fish.
When we study Leptospira, everybody said, go for rodent. Then, because one of my PhD students were working with the other student, I said sample all animals, and we found new records of new species, of species that haven't been recorded before. And they are positive of Leptospira. So these are the sort of things that we should explore, because he already been very successful with that primer. So maybe you can just replicate the study.
We try to the time of infection is very critical. It is very, it applies to medicine. We want to do a rapid diagnosis, rapid. Whereas in your part, you want to analyze, then you can culture first, and then you confirm by PCR.
Dr. Nobi, you have a question?
Yes. I'm not a medical scientist, therefore my question may be a bit silly.
Yes,
However, your presentation suggests that actually this bacteria exists in many places. Then what would make such a difference when flood comes? Why after flood you suggested number of cases in humans increased? Why you needed, for bacteria needed flood?
Yes. This is climate change, increasing temperature, flooding, severe flooding. This is climate change. So in climate change, especially in plant, the bacteria will multiply much more rapidly because of the available of water and moisture in the soil, or nutrient in the soil. So normally the bacteria, we take samples from the surface and also from the underground. So during flood, this bacteria can come up to the surface, and they are more proliferative compared to the dry season. We don't have report in the Middle East. In the desert, cases of the
It's dry.
in the desert. They have different camel, they can have MERS-CoV, the virus in camel. So maybe in tropical countries. So during flood, this analogy also occurs in insects. Mosquito, they breed much faster, isn't it? Some mosquito and some other insect, they breed much faster when temperature increases, isn't it? When they have temperature very rapidly. So that predisposed to as a vector of disease, carrier of disease.
I can explain the relationship between this disease, melioidosis, and climate change is he mentioned about the flood in 2014. That was the El Nino phenomenon. Now is the El Nina phenomenon, and it's a cyclic sort of thing, and is an indication of the climate change. So this is where I bring in Dr. Sakilola and his group to work on the big data. We have to rope in one guy from, I think, INOS, who is working on climate change. And And having all the data from him, because they've been working for a long period of time, and we can download all the climate data
Yes.
and try to model and see the pattern of El Nino and El Nina. So the El Nino is a big thing, the El Nina is the little sort of flooding that's occurring now. So that relates to the climate change.
To please correct if I'm wrong. My understanding is, so that bacteria may exist in many places. However, when flood would come, they probably multiply in number, and
Correct.
humans would
Correct.
be exposed to a larger number
Yeah.
of
Correct.
bacteria.
Correct.
Probably this is why it would trigger some
Yeah.
sort of diseases. Am I correct?
Correct. So during the drought, they would just be sleeping somewhere in the soil. But when the moisture start to be abundant, then they will be multiplying very rapidly.
I think in the flood season, it's difficult for us to contain it because certain people they are lacking in hygienic.
That's why the
Ini ialah lubang satu di luar hatchery
humus.
Aquatrop UMT pada hari Isnin 29 hari bulan Disember. Our 11 sites ni our sampling site number 11 di sekitar hatchery Aquatrop UMT. This is the surrounding area. This is the mengabang bangunan hatchery, big building here.
Very tough.
Ni lubang nombor 4.
Very tough, huh? Very tough.
Tu Zulika. Ini lubang nombor 5 belakang hatchery Aquatrop. Ini ngabang brackish water. Prof Karim dengan Zelika busy. Ini ialah sungai yang bermula daripada Uniza, dia pas UMT, dan kita boleh check apa dia ada di sini. So we take both water and soil sample at this flowing river. Ini sungai yang mengalir dekat jambatan tepi Aquatrop. Sungai ini asalnya daripada Uniza and up dalam kampus UMT. Dulu ada mangrove, dah banyak yang mati.
Awal sebelumnya.
Air bukit-bukit tu dia boleh. Pengkat ni? Dah boleh?
Memang pekat ni memang sepenuhnya air tawar lah. Dia akan membesar dalam itu.
Jadi pengkat macam ni sudah boleh untuk dimasukkan dalam kolam.
Ya.
Ini hatchery untuk udang galah. Jadi Prof Karim,
Umur ni lebih kurang ni dekat 2 bulan